Good day, class. Today we will be doing the factorization method called difference of squares, or as it's abbreviated, DOTS. What is the rule? So if we have x squared minus y squared, that can be written as x minus y into x plus y. That's the rule. For example, if we have 4 squared minus x squared, that can be written as 4 minus x into 4 plus x. In order to use difference of squares, we need to know what are the square numbers. So 1 squared is simply 1 times 1, which is 1. 2 squared is 2 times 2, which is 4. And in a similar manner, 3 squared is equal to 9. 12 squared is equal to 144. Memorizing this is very important and will help us not only in grade 10 but also grade 11 and 12 as well as at university. Let's try a question. So 4 minus x squared. Now we know clearly that that's a square. So is that a square? If we go to our table, we can see that 4 is a square and it is 2 squared. Therefore, this is going to be 2 minus x, 2 plus x. Let's try a different one. Let's say 16x squared minus 25y squared. Again, where does 16 lie on the right hand side? So 16 is here. So we're going to have an open brackets. Instead of 16, we put the root of it, which is 4x minus, where does 25 lie? So 25 is there, and so that's just 5 squared, so it will be 5y into 4x plus 5y. What happens if we have 9 over 4 x squared minus 49? Again, same principle. 9 is here, so it's 3 squared, and so we keep the same fraction. So instead of 9, it becomes 3 because 3 squared is 9. Instead of 4, we write 2 because 2 squared is 4. So that 4 becomes 2 there, and we just keep the x. 49 we know is 7 squared, so it's minus 7, and then 3 over 2x plus 7. So this shows you that difference of squares not only applies to natural numbers and variables but also to fractions. The next case. So the next case is, what is a square? What is a square? So a square, if I have to put it simply, is an even power. So anything that has an even power is a square. For example, if I had to write x to the 4 minus y squared. Now we definitely know y squared is a square. But what about x to the 4? Well, it is because 4 is even. Therefore, all we need to do is we need to halve the power. So it becomes x squared minus y, x squared plus y. So when you're going there, you need to halve. So we're halving the power. So if you have, for example, x to the 6 minus 1. Now if it's minus 1, it's always 1 is basically 1 squared. 6 is even. Can you see that 6 is even? 6 is even. What's half of 6? Half of 6 is 3. So x to the 3 minus 1, x to the 3 plus 1. And this is a really good question because as you learn in grade 10, you can further simplify this using addition of cubes and this using difference of cubes. So this would be a 4 mark to 5 mark question if they asked you to factorize this. But for today's lesson, we'll just stick to difference of squares. Now let's continue with difference of squares. So far we've covered two things. So firstly, what are square numbers? So square numbers are, we had our list here. 1 is a square number from 1 to 12. If you are unsure, for example, if they tell you 169 minus x squared, and then you say, but sir, 169 is not part of our list. What can we do? How do we confirm if a number is not part of the list? Well, then you simply take out your calculator, you plug in the square root, put in the number that you want to confirm if it's a perfect square. So you put this into your calculator, and the calculator will tell you that this is 13. If you get a straight integer, then you can do difference of squares, because now we know that 13 squared is 169, so the square root of that number, so you'll have 13 minus x, 13 plus x. You might say, sir, if we could plug it into our calculator, why do we need to learn this? Well, we need to learn this to improve our maths. We need to improve our maths, improve our cognitive ability, improve our logic. If it's too much of a headache to learn it, just plug it into your calculator to confirm if it's a perfect square. Of course, if it's not a perfect square, you won't be able to use difference of squares. For example, if it's 8 minus x squared, there's nothing you can do at that point because 8 is not a perfect square. So here we cannot do anything because that's not a perfect. Now that we covered this here, let's look at the second thing that we learned. So we learned about all the integers that are perfect squares, but we also learned something else. We learned, so what are square numbers? It's both these integers and which goes on, for example 169, and even powers of variables. We also learned that fractions can be perfect squares. So if you have a perfect square over a perfect square, then it is also a perfect square. Example of this is, let's do 4 over 9 minus x squared. Now 4 is a perfect square, and that's 2 squared. 9 is a perfect square as well, therefore that becomes 3 minus x and 2 over 3 plus x. So let's not be scared of fractions. So that covers what are perfect squares. Now let's see how they could be tested. So the most easiest way that it can be tested is your standard x squared minus 1. That would just simplify to x minus 1, x plus 1, because we know that 1 is simply 1 squared. The second way it can be tested is if you're given coefficients in front of the variables, for example 16x squared minus 4. Let's not use 4, let's use 9 actually. 16x squared minus 9. The square root of 16 is 4, so it becomes 4x minus 3, 4x plus 3. The next is when you have to take out a common factor before you do difference of squares. So let's assume we had 8 minus 2m squared. Now both 8 and 2 are not perfect squares, but they do have a common factor, which is 2. So I can say 2 open brackets. 2 times what gives me 8? 2 times 4. 2 times what gives me 2? It's 1, so it's minus 1m squared. Since it's 1m squared, I don't need to write the 1, so I'm going to take out that 1. So it's 4 minus m squared. And this looks like difference of squares because 4 is a perfect square and clearly m squared is a perfect square. So that can be factorized as 2 minus m, 2 plus m. So you see this coefficient will stay on the outside, right? You keep that on the outside. All we're doing is this entire inside red part factorizes into the bottom red part. So that factorizes there. 3x to the power 4 minus 48. We can start by taking 3 as a common factor. If we take out 3, we'll have x to the 4 minus. Then in the side, we can use our calculator. 48 divided by 3 is 16. So this would be x to the 4 minus 16. 16 is definitely a perfect square, but now we are unsure if x to the 4 is a perfect square. But recall we said that even powers are perfect squares, therefore we just need to halve the power. So 4 divided by 2, so if we halve the power it becomes 2, so it's x squared minus 4, because 4 squared is 16, and then it becomes x squared plus 4. Now you would think that we are done, but we clearly see that this brackets becomes difference of squares. So to make it easier for us to understand, everything that stays the same, I'm going to write it in black. So there we are. So that's staying the same. But the inside part is going to be factorized. So that x squared minus 4 becomes x minus 2 into x plus 2. And this becomes our final answer. Now, if you're factorizing, you never open brackets because then we're basically undoing everything that we've come this far and completed. Let's try another question where we have a variables as common factors, so that's also possible. So let's say, for example, question 5, we have 12a cubed b minus 300 ab cubed. Can 12 go into 300? I think it can. So in my calculator, I'll say 300 divided by 12, 25. Perfect. So I know that 12 is a common factor. It will come out here and it will come out from there. Now when I'm looking at a cubed b and ab cubed, I need to take the smallest power of a. That's how you do common factor. So if I'm looking at a to the 3 and this is a to the 1, the smallest power of a would be a to the 1. If I look at b, it would be the same thing. The smallest power of b is just the b. 12 goes into 12 one time. If I take out an a from a to the 3, that becomes a squared. When I take out the b from there, nothing will be remaining. Then I'm going to say minus. 12 goes into 300, or 300 divided by 12 is 25, so that becomes 25. If I take out the a from there, I'll be left with nothing. Then if I take out the b from b cubed, I'll be left with b squared. So this is simply 12ab into a squared minus 25b squared. That we know is difference of squares. So that becomes a minus 5b, a plus 5b. In previous lessons, I went over common factors, and so we would have covered taking out 12ab as a common factor. So you can just check for those videos. Let's say we have a plus b squared minus 1 over c squared. The reason I'm doing this question is that I don't want you to get scared when working with different alphabets. So I want you to treat this as a plus b squared, we'll leave it as is, minus, now 1 is basically 1 squared over c squared. Treat this entire thing as your x and treat this entire thing as your y. So it's basically x squared minus y squared, and we know the rule, x squared minus y squared is simply x minus y. So if this is my x squared minus my y squared, so a plus b is x, 1 over c is y. So that becomes a plus b minus 1 over c into, I'm keeping the brackets just so it's easier for us, a plus b plus 1 over c. Then I can drop the a plus b bracket, so it becomes a plus minus 1 over c into a plus b plus 1 over c. And there we go. Difference of squares, not that difficult. Okay, cheers, bye.